Okay, thank you. I work at Scapin's Eye Research Institute Morphology Core, which is part of Mass Eye and Ear in Boston, performing ophthalmology research mainly. Full disclosure, I am part of a IP license agreement of the grid staining apparatus with the manufacturer. Full immersion batch TEM grid staining is really low tech and yet efficient. And over the many decades, there have been numerous apparatus, in-house, lab-made, many of which have been published or not published, both manual and automated solutions. So the one that we were using, the old Hiraoka grid manual batch stain kit, was no longer commercially available for some time, with many of the parts wearing out, particularly the grid support plate. Modifications were made with new materials and features the ability to line the staining trays with an inert material, parafilm, which of course is a standard surface for grid-on-drop aqueous contrast staining, and is easily disposable for cleaner results. The majority of our samples in our core range from human to mouse, rat, rabbit to zebrafish, mainly mouse ocular tissues, prepared for conventional routine TEM. Here's an overview summary of the routine staining procedure we use with single slotted coated and uncoated mesh grids using a uranyl acetate, some lanthanides, and modified Sato's lead stain with successive DI water rinses, the DI water being pre-boiled and cooled using the staining kit. Now, I wanted to show you a, okay, here, let me try to, I wanted to show you a video overview of the setup, preparation, and stain procedure using the kit. For paraffin lining, it's best to pre-peel the paper, then use a well mold tool to die plunge into the tray, seal the edges, then peel away. The volume is around 5 mLs for the full tray. For minimizing the volume, a well insert can be used, and the edge of the tool can be used, and then a 2.5 mil volume is generated. Loading grids into the support plate, just try to offset with before you clip in, so you have an edge to unclip. You load the grids, whether they're slotted grids, in an organized and documented fashion. Try not to get the film over the slits. You unclip, they're ready to use. Staining with uranyl acetate here is displayed. You lift up at an angle and carefully insert. DI water rinses, you do the same. I place a cover over every 2 trays. I immediately filter and use the lead stain. Then you dry and unload with lens paper, unload, and then it's ready to be stored and TEM imaged. The kit components are available individually too for those people who might be using the old Hiraoka stain kit. And I did want to just to briefly show some results of a stain contrast test of using the non-radioactive lanthanides that have been previously published, gadolinium acetate and neodymium acetate, compared to the old school tried and true classic uranyl acetate lead. There are subtle contrast differences, particularly in the heterochromatin mitochondria, and in our cases with imaging RPE, Brooks membrane. Neodymium acetate gave a subtle stain precipitate, which was disappointing. We are really routinely using uranyl acetate lead. And we have used it, this kit, for some time now, for nearly 17 years. And it's, I know that there are automated solutions, but for small core labs like ourselves, that can't really justify the expense of an automated. We find using batch staining simple and easy to use, as others have published over the years. Thank you.
Thank you, Phil. Any questions coming from the audience? Otherwise, I'm going to ask Phil about your trial of the uranium acetate substitute. So basically, you conclude still uranium acetate is better than all the rest of them. Is that right? Or you're seeing there's ways? You are muted now, Phil.
Sorry. Overall, yes. I would say that there would maybe, if you're training new students and there's there could be some safety issues, maybe initially try the non-radioactive lanthanides, or if it does depend upon the project, but for we as electron microscopists are always trying to achieve specific maximum optimal contrast of membranes, and especially in the 3D EM applications.